Right. Two blocks move on a straight level track where friction between the two objects in the track is negligible. Block B of mass 4 kg is initially at rest and block A of mass 2 kg slides to the right and collides with block B at time t equal to 3. There you go. The figure shows the position x of block A as a function of time, which of the following is most clearly the momentum of the block B after the collision. All right. So this is a question on collisions, of course, and conservation of momentum. So this is our floor, frictionless floor, and two blocks move on a straight level track where friction between the, okay, block B initially at rest. So block B initially at rest. Do we know the mass of block B? Yeah, 4 kg. Block A, 2 kg, slides to the right and collides with block B. Okay. We don't know what speed, etc. Okay, doesn't matter. So this is 2 kg and it collides with block B at 3 seconds. That's all we know. But I think since this is the value of x as a block A as a function of time, this is A and this is B, we can just find the speed of block A from this information, right? Because before 3 seconds, there is no collision. So since the slope of displacement versus time curve gives the velocity, here we can just find the slope, which is the rise of 6 units and a run of 3 units. So 6 over 3 is 2. So the velocity of A before the collision is 6 over 3, which is just 2 meter per second. So it was traveling at 2 meter per second before collision occurred. Okay. After collision, to the right and collides it. Okay, which of the following most clearly gives the momentum of block B after the collision? Now, I don't know what is the speed of A. I don't know what is the speed of B after the collision, but we are supposed to find the momentum of block B, and I have to know the momentum of block A as well because after collision, what happens to it, I don't know. But I know that its position changes like this. So I can again find its velocity, right? In this case, it has to be negative because that's a negative slope. So there is a rise of 6 to 4 units, which is obviously minus 2. And there's a run of 3 to 5, which is just 2 units. So 2 over 2, which is minus 1 meter per second. So indeed, actually, this starts moving to the left. And now I know that the momentum is conserved, right, of this entire scenario. So the initial momentum of the situation should be equal to the final momentum. What is the initial momentum? Initial momentum is only of the block A because block B is at rest. So I'm going to write first that PA initial plus PB initial is equal to PA final plus PB final. PA initial is mass times velocity. PB initial is 0 because B is at rest. PB final will be mass times velocity. Velocity is minus 1. And PB final is what I need to find. So I'm going to say that this is 4, this is minus 2, and this is PB final. Adding 2 both the sides, the answer for PB final is going to be 4 plus 2 kilogram meter per second. So the answer should be option D. Fortunately, it is indeed in the option. So they tested us on a little bit of kinematics and eventually momentum conservation.